tools to actually generate a picture from the ESUG test. So generalize that. So how do I use usually unit tests? It's simply by putting some assertion in a special class, and this assertion basically says whether a method return a valid play space or not. But I was wondering whether there is nothing else that we can gain from tests. For example, non-functional properties such as architecture conformance and some patterns, some execution patterns. Some other things such as the coverage or some escaping values. So one way of tackle this question is by defining a history model for classes. So whenever I run a unit test in an ESUG class, then I generate a history for a class, and then I will display this class on the screen by using some color maps. So now I will show you this history mechanism. So here I have very simple test. Just merging two rectangles. Just take two rectangles, merge them, and assert that the resulting rectangle is the merging of the two. So here there is when I execute this test, the first one is executing. So there is nothing that has to do with rectangle and class rectangle. So rectangle is the class I'm interested in. So there is nothing related to rectangle. Then I go to the second line, which actually creates an instance of the class rectangle using the method left, right, top, bottom. So this class method creates an instance of the class rectangle and then performs the method set origin corner on this rectangle. So every message is that an instance of the class rectangle will receive, then it's going to produce a column in this graph here. So the second line is identical to the first one, and then here I have the merging. When the merging is sent on the class rectangle, then merging calls the class corner, which calls the class origin corner, and then calls the method set origin corner on an instance of rectangle. So like this, I can build my history, like set of columns. So each column is made of frame, and each frame actually represents one method called stack frame. So there is nothing magic there. And each frame knows about the receiver, the arguments, and the method name. And then now, so here this is just the three first step of the history, but I can have something like way bigger. And then I go into each frame, then I can create a color map and display this history. So for example, I can have something like this. This example I obtained from here. And here each color says that, so each color is a sample package. So here this graph shows, this graph has been produced by the test unit name in the PID command test. And then at the end of the test, I can have this graph here is produced. So it's using one color map. So there are few things that you can see, such as some small here teeth, like castle. So I don't really know what it means, but I have this kind of pattern of canapiers. For example, here this one, say, I monitor the method plus, and I open 4 windows in Squid. So then I have this graph. Then there are few other maps, such as each color here is each color is a class. So I mean that when this test is executed, I can see all different classes that are involved within this test. Then I can do such by using different new color map, I can see what are the values that I escaped. So here the range is the first bottom line here shows what are the instances, the variable that I passed when a method call is sent, what are the instances are passed, and the red is the self-reference that are passed to an object. Yeah. So here so I can have some other graphs. So here I'm just in the class PR header, and this graph shows that all the methods involved, all the methods that belong to the class PR header are displayed. So the white one, there are some other methods. So maybe I can do a demo. Okay, so here this is the PA image. So when I run it, so you see the, oh no, sorry. So here this is a peer image. So for example here I run some tests. So this is just to show you the speed, the overhead that Kerala will take, which is not that much. So when I load Kerala, the only thing I have to do is just to put the annotation with my my SUnit class. So here this is the hierarchy of different SUnit classes. So let's put here the root. So in each class here, made by Lucas, I believe, then there is a method here which is the actual class that returns the class that the test is supposed to test. So here I have the different method here. Then here I just return an array that contains this class here. So when I run here sorry. Well, yeah, I'll run the test again. And for each test that pass, then I have a history as is generated. Okay, so now I can browse the list of history that has been generated. So I have quite a few of them. Now I can filter them and say, okay, so let's say that I'm interested in history that contains more than, let's say, 60 moments. So a moment is a column in my history. And then now I can select one. And here I have the list of color maps that I can apply to them. So let's pick this one. So here I see. So here I see each color is one package. So I see that when the method here test from string, which is the one right. Okay, so here I can have some. And then for then I can so here I can see all the packages involved into this test. And I can see some other so here I can see, for example, the other this one shows the different methods involved into the test that belong to the class PR document description. Here I can see different objects interacting. So it means that in that case I have three different colors, and this test, the test I'm visualizing, involves three instances of the class PR document rectangle. And here I see all the classes involved. And this one is, for example, all the different objects involved into this test. So please don't ask me what this thing is good for, I don't know. But I don't know, but that's interesting, the fact that you can have some picture you can gain from.
Excuse me.
Yeah.
I missed something, I think. What's each line like? What's the take?
All right, so.
Sorry.
Oh. I don't know whether I can read it or not. So. So here, for example, when I press here on a small frame, it means that this frame corresponds to the class, to the method perform test on the class that is on the class PR document description.
Okay.
And
on each line is a new frame?
Yeah, so each line, so actually depends on which color map you use, but in that case, I don't know which one is okay, so in that, so here, for example,
we change a bit the order of the presentation because we are already late on, so that's not a problem. Gary will show us. Normally, when you think about split, it sucks.